How do I find the sine of 3x using a multiple angle formula? Well, first of all, I rewrite sine of 3x as sine of 2x plus 2. Now, why do I do this? Because this can now be broken down. This can now be broken down. So I have I have sine of 2x cosine x plus cosine 2x sine of x. So I use the sum of sine formula to go from this line down to this line. And now I'm going to use the double angle formulas. And instead of sine of 2x, I'm going to write 2 sine x cosine x. Bring down my cosine x. Bring down my plus sign. And instead of cosine of 2x, I'm going to write 1 minus 2 sine squared x. And I'm going to bring down the sine of x. I'm now going to use some properties of algebra. I'm going to multiply my cosines together. And so now this term becomes 2 sine x cosine squared x plus, I'm going to distribute the sign and get sine x minus 2 sine cubed x. So, referring that cosine squared x, knowing the Pythagorean identity, sine squared x plus cosine squared x equals 1, I can sub in for cosine squared x 1 minus sine squared x. I still have my 2 sine x out in front of it. And I still have sine x minus 2 sine cubed x on the end. So I ran out of room, so I copied the bottom of the formula to a new page. And so now, what do? I can distribute. So this becomes 2 sine x minus 2 sine cubed x plus sine of x minus 2 sine cubed x. And so this is now equal to 3 sine x, because I added these terms together, minus 4 sine cubed x, because I combined those terms together. Please keep in mind that at the very start of the problem, I was manipulating and I was trying to figure out what sine of 3x was equal to. And so the sine of 3x is equal to 3 sine x minus 4 sine cubed x. So if I have sine of the fourth x, I could simply rewrite that as sine squared x to the second power. Now the reason that I do that is because I have a formula for sine squared u. And the formula is 1 minus 2u over 2. So I can sub in for sine squared x. I can sub in 1 minus cosine of 2x over 2, and this quantity is squared. Now, if I apply my squared, this means that in the numerator, I'm going to take 1 minus cosine of 2x times 1 minus cosine of 2x, and in the denominator, I'm going to have 2 squared. So my denominator basically becomes 4, and my numerator becomes 1 minus 2 cosine of 2x plus cosine squared of 2x using, I just foiled my two binomials. Now, I'm going to factor out a fourth, and I'm going to have 1 minus 2 cosine of 2x plus cosine squared of 2x. Here's another example of referring to a formula. Because cosine squared u is equal to 1 plus cosine of 2u over 2. That is a power reducing formula on page 377 of your book. So in for cosine squared of 2x, I can put 1 plus cosine of 2x all over 2. Now I still have my negative 2 cosine of 2x. I still have my 1 out in front, and I still have my 1/4. I do have one glaring error that I need to correct. When I use this formula right here, my u that I'm using in the formula is supposed to be 2x. So when I sub in 2x right here, 2 times 2x is 4x. So that's supposed to be the cosine of 4x right here. So I ran out of room, so I went to the next page. So what does this become? Fixing my mistake, 2x is supposed to be 4x from the previous page. So now we're going to distribute this 1/4 to all 4 terms. 1 times a fourth is a fourth. A fourth times negative 2 cosine x would be negative 2/4, which is negative 1/2 cosine of 2x. Keep in mind that this fraction is over 2. So this 1 right here is a half. So a half times a fourth is an eighth. And then I have cosine of 4x over 2. And so cosine of 4x over 2 times a fourth is 1/8 cosine of 4x. Now, what can I clean up? 1/4 is 2/8. 2/8 and 1/8 is 3/8. I have negative cosine minus 1/2, cosine of 2x plus 1/8 cosine of 4x. This would be an answer. They, however, chose to factor out an eighth. And if you factor out an eighth, you're left with the following. 3 minus 4 cosine 2x plus cosine of 4x. And again, my goal was to rewrite sine to the 4th power of x as a sum of first powers of cosines of multiple angles. Again, we're practicing using multiple identities and formulas to rewrite the original equation.